Question 11 is all about conditional probability. As you can see in part 1, it says events A and B are independent. So it's always a good idea if events are independent to straight away just write down that the probability of A times by the probability of B will equal the probability of A and B. You can be pretty sure you're going to need to use that at some point whenever it says two events are independent. So that means that the probability of A times the probability of B is going to equal 1 over 24. Can't do anything else yet, so let's just leave it as that. You also know that this is true, that the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. If you ever forget that formula, just think about a Venn diagram. If you have a Venn diagram, this is A, this is B, A, B. This is the probability of A and B in the middle. Then if you add up the probability of A, which is everything in here, plus the probability of B, which is everything in here, that will count this middle bit twice. So if you want the probability of A or B, you want to subtract the middle bit. You don't want two of the middle region, so you have to take away the probability of A and B away from the probability of A plus the probability of B, to leave you with the three regions you actually want. When it comes to probability of A or B, you want this, you want this, and you want this. So just take away one of these. Anyway, looking at this formula then, probability of A, we don't know. Probability of B, we don't know. But we do know this is 3/8. We do know this is 1 over 24. So the probability of A plus the probability of B is 3/8 plus 1 over 24. So add those together and that will give us 5/12. So we now have simultaneous equations. We've got this one up here, this one down here. You call this 1, call this 2. We want to solve those simultaneous equations. So from 1, we can rearrange 1 to get the probability of B on its own, which would be 1 over 24 times by the probability of A. So that can now be substituted into here. So if we sub that into number 2, we'll get the probability of A plus 1 over 24 times by the probability of A equals 5/12. I think good idea now is to multiply everything by this denominator, so then we won't have any fractions at all. Then running out a bit of space, just clear a bit of space. So let's multiply all of this by the denominator, which is 24 times by the probability of A. If we do that, we will get 24 times by the probability of A all squared. By the way, you might find it easier in this question you could just let x equal the probability of A and maybe let y equal the probability of B if you want, just to save a bit of writing, but I've already started now, so it's a bit late for that. So let's carry on going. Anyway, we've got plus 1 and that equals 5/12 multiplied by 24 times the probability of A. That's going to be the same. 24 divided by 12 is 2. So that's actually just going to be 10 times by the probability of A. So let's write that down there, 10 times the probability of A. Now this looks like a quadratic now. So let's just get it equal to 0. We'll keep this as it is on this side. And we'll subtract the 10 times the probability of A. Still got plus 1. So that equals 0. If you use your calculator to solve that quadratic, so solve quadratic, you should get the probability of A equals two answers. One is 1/6, and the other one is a quarter. So using your calculator to get those values, if A is 1/6, then that means that B, you should find that the probability of B is well, just using, where is it? Oh, I've lost it. Oh yeah, down here. So if you know what A is, if you do 1/24 times by the probability of A, you'll get the probability of B. So 24, if you do 24 times by 1/6, that will be 4. So the probability of B will be a quarter. So if A is 1, so one solution is the probability of A equals 1/6 and the probability of B equals 1/4. However, if you have the probability of A is 1/4, again, if you substitute it, that value into there, you do 24 times by a quarter, that's 6, do 1 over that, you'll get the probability of B equals 1/6. So these are the solutions. A quarter and 1/6. One of the values will be a quarter and one of them will be 1/6. Part 2 is completely different. We're not talking about A and B anymore, and we're not told anything about C and D in terms of being independent or mutually exclusive. So you've just got to use the information given to try and work out what the probability of D given C is. With all of these conditional probability questions, I think it helps straight away to write down this formula, because you're probably going to use this formula to work out the answer. Whatever is here, whatever is second, remember this line means given that, whatever is given, in this case C dash, that always goes on the bottom. So if any time students get this formula wrong, it's because they put the wrong thing on the denominator. So make sure you get the formula correct. Now we'll come back to the numerator. The probability that C doesn't happen, C dashed, well, that's fairly straightforward. That's just 1 minus the probability that C does happen, and we're told that in the question. We're told that is 0.6. So the denominator here is 0.4. Now the numerator is not so obvious to work out. And working out the probability of D, the probability that D and C doesn't happen, the way I would do it is through a Venn diagram. I'm sure there are other ways of doing it. You might have a much better way of doing it than me, but I would do a Venn diagram. This is C, this is D, and what do we know? Well, we know that probability of C all the way over here is 0.6. We know the probability of D, which is all of this, is going to be 0.3. And we want to, before we can work this out, work out that numerator, it's going to help if we can find out what's in the middle bit here. So what's in this middle section? The way you can do that is to use the formula probability of C and D is the probability of C plus the probability of D minus the probability of C or D. You used this in the previous question, so that would be 0.6 plus 0.3 minus C or D, which we're told in the question is 0.8, and that gives us 0.1. So that red section up there, I just rub this out, this red section is going to be 0.1, which means we can fill in everything else now. This would be 0.2, this would be 0.5, and that leaves us with 0.2 left over because they've got to add up to 1. So going back to our question, what do we actually want to work out? Well, we want to work out this, and then we can divide it by 0.4 and we'll have our answer. Now the probability of D and C doesn't happen means we can't have this because C happens here. So where D happens and C doesn't happen is just this here. So that's the bit of the Venn diagram where D happens and C doesn't happen. So we can write that in our formula. So we can put that in here, and that will be 0.2 divided by 0.4, which will give us our answer of 0.5, which I think is the final answer there.